This video is explaining how to prove transformations. So we're proving transformations. When you're proving transformations, you're going to predict what transformation is occurring. What that means is you're actually going to think about what does it look like is happening? What do you think the transformation is? Using all of your resources, what does it kind of look like is happening? But you don't just stop there. When you predict, that's just what it is. It's a prediction. It's what you think is happening. What you want to do is use the properties of the transformations to actually prove it is what you think it is. So if you're predicting it, you actually want to use the properties to in fact prove that it is happening. You don't just want to guess. You want to check to see if it really is. Because if you predict that it's a reflection, but you show that it's not, then your prediction was wrong. And then you can always predict something else. So we're going to use the properties to actually prove that it is, in fact, that transformation. So going over the transformations, I'm going to talk about the properties of the transformations. For translations, the property of translation states that AA prime, BB prime, and CC prime are parallel, and that AA prime, BB prime, and CC prime are also congruent. Now what this means is that from the pre-image to your image, however many there are, I've only used 3 for a triangle, but there could be multiple different letters. So you could have AA prime, FF prime, GG prime, whatever letters you have to prove that all of them, from the pre-image to the image, pre-image to the image, pre-image to the image, are parallel. You then have to use that same segments, AA prime, BB prime, CC prime, and prove that they're all congruent. That means the same length. They'll be segments, so they should be the same length. For reflections, the property for reflections is that AA prime, BB prime, and CC prime are also parallel. But it's the same thing on translations, which is why you have to prove all of the properties. Because so many of the properties state that something is parallel or congruent, so you need to make sure that you know which property goes with what. So parallel goes with both translations and reflections, but the second property is what you need to look for reflections as well. This really proves that it's not a translation. It's that the line of reflection, whatever it said you're reflecting over, whatever you think it is, that axis of symmetry, that the line of reflection is the perpendicular bisector of AA prime, BB prime, and CC prime. So we'll already have these lines because we have to prove that they're parallel. Then we have to see that that line of reflection is perpendicular to all of these lines, and it also is the bisector of all those lines. Bisector means cuts in half. So the line of reflection has to go through the middle of all of these lines. We don't have to prove congruency. We just have to prove that the line of reflection is perpendicular and goes through the middle. So you actually have 3 things you have to do here. You have to show parallel, you have to show perpendicular, and you have to show bisector. For dilations, you have to prove that segment AB, this is your pre-image, one of your segments of your pre-image, is parallel to the image segment, the same image segment, so A prime, B prime. Then you have to prove that the pre-image BC is parallel to the image of B prime, C prime. And you also have to show that the pre-image AC is parallel to the image A prime, C prime. You have to not show that from A to A prime. This is actually showing that the original pre-image, all of the segments from the original image, so the pre-image, are parallel to the new image. You also need to show that AA prime, BB prime, and CC prime will all pass through the center of dilation, which in our case is generally going to be the origin. So what you want to do is connect your A and A prime and have it see if it will go through the origin. You'll connect B and B prime and see if that line will extend through the origin. C and C prime and see if that line will extend through the origin. If all three of them do, and you can see that they're parallel, then we should have dilation. And then you figure out what is the dilation by figuring out your scale factor by doing your image divided by your pre-image coordinates. You have to prove that it's a dilation, and then you can find your scale factor. Now the last transformation is a rotation. This one is where you're proving that AR, segment AR, is congruent to A prime R. This is the pre-image to R, where R is the center of rotation, which will generally also be the origin, 0, 0. So we want to say that from A to the origin is the same distance as A prime to the origin. We'll do the same thing with all of our segments. And again, I used A, B, and C just to prove that it's a triangle, but you would do it for every single one of your segments. So if you have 7 segments, you have to do things 7 times. So please be careful and please make sure that you are paying attention to which rule you have to use. Now, what I'm going to do is I'm going to talk about the different things up here. We had parallel, congruent, perpendicular, and bisector. We had parallel, passes through the center, so it just connects the line, and then congruent again. So we really have 4 words down here that we have to know how to do. Now, if we're talking about parallel, if the words say parallel, we actually have to show that the slopes are the same. So that's our rise over run. You just have to show the rise over run. And if you have to simplify it, simplify it. If you don't have to simplify, you already see that they're the same, that's perfectly fine. So when you see that word parallel, I'm going to highlight in yellow. And everywhere I see parallel, I'm going to highlight in yellow. Say that I know that I have to do parallel, so that's down here. I have to show that. On reflections, I have to show parallel. On dilations, I have to show parallel. I have to show multiple different things parallel. But rotation, I do not have to show parallel. The next one is perpendicular. Perpendicular, you actually have to show that slopes are opposite reciprocals. If you remember what opposite reciprocals are, it's flip fraction, and change sign. Flip the fraction and change the sign. So if you have a 2/3 as your pre-image slope, or since we're dealing with perpendicular here, your AA prime, BB prime, CC prime are all parallel and they have 2/3, then the line of reflection should have a -3/2. So perpendicular goes with reflections. I'm going to highlight perpendicular in pink. And everywhere I see perpendicular in my rules, I'm going to highlight in pink. Have it in reflection. That's the only one we have it in. It's just in reflections. We also have the word congruent, which we see the symbol as the equals with the squiggle on top. The equals is saying that they are the same size, and the squiggle means that they are the same shape. So this is an equal sign, and this is a similarity symbol. The equality and similarity, so they're equal and similar, so it's same size and same shape. Now for congruent, what you do is you use the Pythagorean theorem or the distance formula. You could do either one. So congruent means you prove that the values are equal using the distance formula. Or you can make right triangles and use Pythagorean theorem. Pythagorean theorem, which is a squared plus b squared equals c squared, which means you will have to take the square root to be able to do it, which is that actually comes from the distance formula. The distance formula comes from Pythagorean theorem. It's just you use coordinates. But instead of using coordinates, I just want to know how long the sides are. So if I'm already using slope to help me, I can use that slope to help me figure out my distance formula as well. So for congruent, I'm going to highlight in green. Congruent symbols, I'm going to highlight in green. So coming up to translations, I have the word congruent. In reflections, I do not have the word congruent. Dilations, I do not have congruent. Rotation, I do have 3 different congruencies. Because these 3 are actually going to be completely different to each other. Just like with these 3 different parallels, these will all have different slopes. So these 2 should have the same slope, but those won't be the same as these 2. These 2 will have the same length between them, but they won't be the same as these 2. That's why you have to do them at 3 different times. That's why I highlighted them at 3 different times. And the last one is bisector. Bisector, again, means to cut in half, but what you really do for that is find the midpoint of A prime, and etc., and all of them, by doing x plus x over 2, y plus y over 2, and then the line of reflection, line of reflection goes through that point. Goes through that point. So the only time we see the perpendicular part, or sorry, the bisector part, I'm going to highlight in orange. The only time we see bisector is on reflection. So translations, you actually have to find 2 different things. You have to find parallel and congruent. On reflections, you have to find parallel, perpendicular, and bisector. But you have to know what you're finding parallel of, what you're finding perpendicular of, and what you're finding bisector of. On dilations, you only have to find parallel, but you have to find 3 different slopes. So you'll have these 2 slopes, these 2 slopes, and these 2 slopes. So really you're finding 6 slopes total just with A, B, and C, because these 2 will be the same, these 2 will be the same, and these 2 will be the same. For rotations, you only have to prove congruency, but you have to prove 6 total things. You have to find 6 distances, because you'll have these 2 will be the same distance, so those are congruent. These 2 will be the same distance, so they're congruent. And these 2 will be the same, so they're congruent. Each of these explains how to find them. So you need to make sure that you do find, if it's in yellow, it's parallel, you have to use your slopes. Perpendiculars in pink, you have to use your slopes. Congruent, I use the Pythagorean theorem. If you know the distance formula, you want to use the distance formula, you can. I use Pythagorean theorem because I can create right triangles on the coordinate plane. And bisector, what you do is find the midpoint, and you know midpoint will be in the middle of our segment. So I can also see, if I see that my point ends up here, I know that's not the middle. So I know it has to be in the middle, so I have to at least get close to it and make sure that that is a correct coordinate. These are the rules and the steps to prove that the transformation is occurring.